Hello everyone, welcome back to the site of resonance. Today we will going to start about the speed of sound in different mediums. In the previous class what we have studied was the amplitude, that is loudness that depends on amplitude. We have studied about the pitch that depends on frequency. We have studied about the intensity and timbre and quality. So those were the characteristics of sound. Today we will going to start about the speed of sound in different mediums. So let's see what is the speed of sound in different mediums. So first we are seeing in solid. So in solids, see what is the structure of solid. In a solid, the atoms and molecules are very close to each other. They are tightly packed. So atoms and molecules are very close to each other like this, isn't it? So this is the structure of solid. So what will going to happen as soon as there will be disturbance, the disturbance will be passed from molecule to molecule or atom to atom. That we know that a wave is a disturbance in which energy get transferred from one place to another without actual movement of the particles. So particles, they vibrate but they don't actually displace from their mean position. So these particles will going to vibrate and they will going to transfer energy to each other in a very short time, because they are very close to each other. So this particle will going to collide with this, that will that, and so on. So the particles will going to collide with each other at a very fast rate. So speed of sound in solid will be very fast, as disturbance will going to travel at a very great pace. Why? Because the atoms and molecules are very close to each other, so they will going to pass the disturbance in a very short span of time. But what will be the case in liquids? See, we know the structure of liquid. What happened in liquid? In liquid, the atoms and molecules are a bit far away from each other like this, isn't it? So whenever there will be a disturbance, this atom will going to travel some distance and then it will going to transfer its energy to the neighboring atom. So there will be a time lag between transfer of energy from one atom to other atom. So speed will going to reduce over here. It will be a bit slow. Here it is very fast. Here it is slow. And now what we will going to see is the third, that is gases. What will going to happen in gases? We know the structure of gas. What is the structure of gas? In gas, the atoms are very far from each other. The atoms and molecules are very far from each other, so they have to travel a great distance before they will going to transfer their energy to the neighboring particle or the atom or molecule. So the time lag over here will be very much, means the speed of the sound will be very less, so very slow speed. So if I will going to make a comparison, I will going to see that velocity of sound in solid is greater than velocity of sound in liquid is greater than velocity of sound in gases. So this is the conclusion that I have drawn from this, that velocity of sound is maximum in solids, means sound travels at a maximum speed in solid comparative to liquid and gases, and it travels at a least speed in gases. Why? Because the atoms and molecules in the gases are far away from each other. One atom is air, one atom is air, so it will going to travel and then it will going to transfer the energy, means there will be a great time taken by the particle to transfer energy from one to another. But in solid, what is the case? In solids, the atoms and molecules are very close to each other, so they will going to transfer the energy in a very short time. So the speed of sound over here will be fast, whereas the speed of sound in gases and liquids will be slow. So speed of sound is greatest in solid, means if I will going to compare that what will be the speed of sound in iron, in water and in air, where it will be maximum? It will be maximum in iron and it will be least in air, because iron is a solid, water is a liquid and air is a gas. As in gas, the molecules are very far away from each other, they will going to take time to transfer the energy, means speed will reduce. And in solids, as the molecules are very close to each other, they will not going to take time, means the transfer of energy will be very fast, means speed of sound will be very fast in solids. Okay. Now we will going to talk about range of hearing. So this was the, before going to range of hearing, I will also going to discuss something about speed of sound. That speed of sound depends on what? What will be the effect on speed of sound with increase in temperature? So first, what I am taking is temperature. See, if I will going to increase the temperature, if temperature increases, what will be the effect on speed of sound? What will be the effect on speed of sound? Let's see. See, as temperature increases, what will going to happen? The frequency of collisions will going to increase. Why? Because the atoms and molecules will start going to move faster. If they were moving at this rate at certain temperature, and if the temperature increases, they will going to move like a bit faster rate than that of previous. Means with the increase in temperature, the speed of atoms and molecules increases. Means the number of collision that will be taking place will be more for a unit time. Means the frequency of collisions will going to increase, hence the speed of sound will going to increase with the increase in temperature. जैसे ही आप temperature बढ़ाएंगे, क्या होगा, जो collisions हो रहे हैं उनकी frequency बढ़ जाएगी. क्यों? Atoms और molecules तेज तेज vibrate करने लग जाएंगे और तेज move करने लग जाएंगे. इसकी वजह से कोलाइड ज़्यादा करेंगे और जल्दी करेंगे, तो क्या होगा, स्पीड ऑफ साउंड इंक्रीज हो जाएगी टेम्परेचर इंक्रीज करने से. तो ऑन इंक्रीजिंग टेम्परेचर स्पीड ऑफ साउंड इंक्रीजेज. और अगर मैं टेम्परेचर को डिक्रीज करूंगा तो वो धीरे धीरे वाइब्रेट या मूव करेंगे. कौन? एटम्स और मॉलिक्यूल्स. तो स्पीड ऑफ साउंड क्या हो जाएगी? डिक्रीज हो जाएगी. क्या हो जाएगी? डिक्रीज हो जाएगी. तो टेम्परेचर बढ़ाने पे स्पीड ऑफ साउंड बढ़ती है और टेम्परेचर डिक्रीज करने पे स्पीड ऑफ साउंड डिक्रीज होती है. ये था इफेक्ट ऑफ टेम्परेचर ऑन स्पीड ऑफ साउंड. नाउ व्हाट वी विल गोइंग टू सी इज द इफेक्ट ऑफ प्रेशर ऑन स्पीड ऑफ साउंड. सो लेट्स सी इफेक्ट ऑफ प्रेशर. अगर मैंने प्रेशर को इंक्रीज करा या मैंने प्रेशर को डिक्रीज करा एट सम टेम्परेचर, एट अ सर्टेन टेम्परेचर, एट अ सर्टेन मीन्स कांस्टेंट, एट अ सर्टेन टेम्परेचर. Let us take the temperature be T. So at T temperature, what I am doing is I am increasing the pressure or decreasing the pressure. So what will be the effect on the speed of sound? See, on increasing temperature, the speed of sound increases. On decreasing temperature, the speed of sound decreases. But अगर मैंने temperature constant कर दिया, टेम्परेचर क्या लिया मैंने, कुछ टी टेम्परेचर लिया जो कि कांस्टेंट. अब मैं प्रेशर को इंक्रीज या डिक्रीज करूंगा तो स्पीड ऑफ साउंड पे क्या फर्क आएगा? देयर विल बी नो इफेक्ट ऑन द स्पीड ऑफ साउंड. आप चाहे प्रेशर बढ़ा दें या प्रेशर कम कर दें, एक पर्टिकुलर टेम्परेचर पे, मैं वापस बोल रहा हूं, टेम्परेचर से हम कुछ भी छेड़खानी नहीं कर रहे. टेम्परेचर इज फिक्स्ड. So for a fixed temperature, for a certain temperature, for a constant temperature, if you will going to increase the pressure or you will going to decrease the pressure, there will be no effect on the speed of sound. There will be no effect on speed of sound. तो प्रेशर बढ़ाने कम करने से एक सर्टेन टेम्परेचर पे स्पीड ऑफ साउंड में कुछ भी फर्क नहीं आता, कुछ भी फर्क नहीं आता. So that was about the speed of sound. It is fastest in solids, then in liquids, then in gases. And as you increase the temperature, the speed of sound increases. If you decrease the temperature, speed of sound decreases. Means the temperature in summers will be more, so the speed of sound in summers will be more, and the temperature in winters will be less, so speed of sound in winters will going to reduce. So there are many questions which are framed on this concept. On increasing and decreasing pressure at a certain temperature, there will be no change in the speed of sound. There will be no effect on speed of sound. Now I will going to talk about the range of hearing. Range of hearing. See, it is again a concept which depends on sensitivity of ear. For different person, the range of hearing can vary from person to person. For different person, it is different because it depends on the sensitivity of ear, that is sensitivity of hearing. So range of hearing for an average person, if I will going to talk, then for an average human being, the range of hearing is from 20 hertz to 20 kilohertz, means 20,000. Kilo means 10 to the power 3. So 20 hertz to 20 kilohertz, or you can say to 20,000 hertz. This is the frequency range for average human being. range of hearing, frequency range. It is frequency range for average person. But I have told you it depends from person to person. For some person it can be slightly less than 20 kilohertz or slightly more than, and for some person it can be slightly less than 20 hertz or more than 20 hertz, depends from person to person. But if a question is asked what is the range for human beings, it is 20 hertz to 20 kilohertz, because this is what we have calculated as on an average. For average person, the range of hearing is from 20 hertz to 20 kilohertz. Children or infants, they can listen at a much greater than 20,000 hertz. They can listen to the frequencies greater than 20,000 hertz also, approximately about 30 kilohertz or 35 kilohertz they can listen. Who? Children and infants. And for as you grow up, as you become old, as your age increases, so old people, their maximum range reduces a bit. They can only listen to 15 kilohertz or 10 kilohertz. Okay, so I have told you it is a concept which depends on sensitivity of ear, that is sensitivity of hearing. So it depends from person to person, but on average it is 20 hertz to 20 kilohertz. Now talking about animals like dogs, they can listen up to 50 kilohertz. Bats, they can listen even more, that is 100 kilohertz, up to 100 kilohertz, and whales even more. There are some birds which can listen below 10 kilohertz also, 10 hertz also. So it depends again from animal to animal. Some animals can listen the more than 20 kilohertz, some can listen less than 20 hertz also. Okay. Now this is known as range of hearing. The sound waves or the longitudinal waves which are less than 20 hertz, they are known as infrasonic or infrasound. Infrasonic wave or infrasound. It is less than 20 hertz. Less than 20 hertz. So 20 hertz से जो कम वाली साउंड वेव है या फिर लॉन्गिट्यूडनल वेव है जिनकी फ्रीक्वेंसी 20 हर्ट्ज से कम है, उनको हम क्या बोलते हैं? इंफ्रासोनिक वेव और इंफ्रासाउंड. और जो वेव्स लॉन्गिट्यूडनल वेव्स या साउंड वेव्स जो 20 किलो हर्ट्ज से ज़्यादा है उनको बोलते हैं हम अल्ट्रासोनिक वेव और अल्ट्रासाउंड ग्रेटर देन 20 किलो हर्ट्ज. सो 20 हर्ट्ज से नीचे वाली साउंड्स को आप क्या बोल सकते हो? इंफ्रासोनिक वेव और इंफ्रासाउंड. ये बच्चों बहुत ही बड़े ऑब्जेक्ट से प्रोड्यूस होती है, लाइक अर्थक्वेक. सो अर्थक्वेक होता है तो कैसा होता है? इंफ्रासाउंड वेव होती है. कैसी वेव होती है? इंफ्रासाउंड वेव होती है. और ये जो अल्ट्रासोनिक वेव है, अल्ट्रासाउंड है, ये बहुत छोटे ऑब्जेक्ट से प्रोड्यूस होगा, लाइक क्वार्ट्ज क्रिस्टल. तो ये छोटे ऑब्जेक्ट से प्रोड्यूस होता है क्योंकि यहाँ पे वाइब्रेशन, नंबर ऑफ वाइब्रेशन देखो कितने ज्यादा है. 20 किलो हर्ट्ज से ज्यादा, मतलब 20,000 रिपीटेशन से ज्यादा रिपीटेशन कर लेगा वो इन अ सेकेंड. दैट इज द फ्रीक्वेंसी, नंबर ऑफ वाइब्रेशंस कंप्लीटेड इन अ सेकंड. सो यहाँ पे 20 किलो हर्ट्ज से भी ज्यादा, मतलब 20,000 से भी ज्यादा रिपीटेशन इन अ सेकंड. वो कोई छोटा ऑब्जेक्ट ही कर पाएगा, बड़ा ऑब्जेक्ट के लिए इतना पॉसिबल नहीं होता. तो छोटे ऑब्जेक्ट से प्रोड्यूस होती है और ये बड़े ऑब्जेक्ट से. इंफ्रासोनिक या इंफ्रासाउंड क्या है? जो 20 हर्ट्ज से कम रेंज की फ्रीक्वेंसी साउंड वेव्स है. और अल्ट्रासोनिक या अल्ट्रासाउंड क्या है? जो 20 किलो हर्ट्ज फ्रीक्वेंसी से ज्यादा की साउंड रेंज है या वेव रेंज है. दैट इज नोन एज इंफ्रासोनिक, अल्ट्रासोनिक एंड अल्ट्रासाउंड. इनके बहुत ज्यादा प्रैक्टिकल एप्लीकेशंस है, लाइक अल्ट्रासाउंड एंड अल्ट्रासोनिक इज यूज्ड इन मेडिसिन्स. यू नो दैट. सोनोग्राफी, it is also used in sonars to navigate in ships. Okay, so now talking about the next topic, we are going to move to the next topic, that is music and noise. So music and noise. What is the basic difference between music and noise? See, what is music? Music are the pleasant sounds. Music are the pleasant sounds which are produced due to repeated, not random, in a mannered repeated vibrations or periodic vibrations से जो produce होती है pleasant sound, soft sound जो आपके कानों को अच्छी लगे, मधुर आवाज, उसको हम music कहते हैं. The pleasant sound which are produced by periodic vibrations, regular periodic vibrations of a particle that are pleasant to listen, that you enjoy, that is music. Apart from those pleasant sounds, the sounds which are produced by random vibrations, that is known as noise. Noise is unwanted. And musical sound is you enjoy it, so it is something that you need. Now music is produced by musical instruments like sitar, guitar, violin, tabla, etc. But noise, it is produced by cars, car horns, machinery parts, etc. Everything else than music is known as noise. जो भी म्यूजिक के अलावा प्रोड्यूस्ड हो रहा है उसको हम क्या बोलते हैं, नॉइज. हम कोशिश करते हैं कि नॉइज कम से कम हो, क्योंकि नॉइज की वजह से बहुत सारे हमारे पास डिसएडवांटेजेस हैं. लाइक इट कॉज some hearing impairments. It also disturbs your mental state because it will going to create more anxiety in you. It will going to give you some headache sort of things. So noise is unwanted. It will going to reduce your work efficiency also. It is easy to study in night, or it is easy to solve some problems, or it is easy to work in night, in late night after 1 or 2 than comparative to before night, that is in daytime. Because in daytime there are lot of noise which are created over here and there. There is cars moving on the roads, there are machinery which are working here and there, people are chirping and talking. So there are so many noise which are created in daytime. But in night time, see, the all atmosphere is completely silent. There is very little noise in the atmosphere, so it will going to give you a pleasant effect to your brain. Your work efficiency will going to increase. That is the only reason you feel very good while working in night comparative to working in day. And music is produced, we know, by musical instrument. It is very pleasant to listen, so there is no need to reduce the music, but there is a need to reduce the noise. So to reduce the noise, there are various methods that we will going to have. We should make machine parts such that it produce less noise, means the friction over there is less, so the noise of machineries got reduced and the energy is also conserved. Okay. And the other thing is, you should not unnecessarily put car horns. You should not talk in a very loud voice. You should play music at a very low level of sound levels. Okay, so that was about music and sound. Now in next class we will going to study about the reflection of sound, applications of reflection of sound and echo. So thank you for today. We will going to continue in our next class.